How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. For today's lesson, we're going to discuss the angles formed by secants and tangents in, on, or outside the circle. In this video, you will learn the definition of secants and tangents, as well as the theorems behind in forming angles between secants and secants, secants and tangents, tangents and tangents, and as such. But before anything else, hit that subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in ML with Sir Ash. Today, we're going to discuss the most essential learning competency-based lesson for Quarter 2 of the Grade 10 Mathematics, which is all about angles formed by secants and tangents. The first question is, what is a secant and what is a tangent? Basically, secants and tangents in terms of circle are both line. When we say line, the end part of the figure is two arrows. Now, secant is a line that touches the circle in exactly 2 points. Meaning that if this is your circle, then it touches or it intersects the circle in exactly 2 points. While, on the other hand, tangent is a line that touches or intersects the circle in exactly 1 point. And that point of intersection is what we call the point of tangency. The question is, how does angles form between secants and tangents? Now, in terms of angles formed in a circle, there are at least 3 cases that will happen. The first case is that the lines or the line segments will intersect outside the circle. In this scenario, you will have a tangent to tangent, secant to tangent, or secant to secant. In case number 2, the intersection will happen on the circle, meaning that the lines or the line segment will intersect or the vertex will form on the circle, which is part of the circumference. In this matter, you could have a secant and a tangent or a secant and a secant. Now, for the case number 3, the intersection will happen in the interior of the circle, meaning inside of the circle. Now, in this case, you will have 2 secants. Now, the question is, what are the theorems behind between these cases? Okay, my dear math learners, remember this. If the intersection will happen outside the circle, what you will do is you subtract the bigger intercepted arc to the smaller intercepted arc and then divide it by 2. Meaning, according to the theorem, if 2 secants or a secant and a tangent or 2 tangents intersect outside of the circle, then the measurement of the angle is 1/2 the difference of the further arc to the nearer arc, meaning the bigger arc and the smaller arc. Easy, right? Now, for the theorem of the second case, if the intersection will happen on the circle, regardless whether the scenario will happen between 2 secants or a secant and a tangent, then the angles is equal to 1/2 of the intercepted arc. You know, my dear math learners, if the intersection will happen on the circle, there is only 1 intercepted arc. And half of that is the measurement of the formed angle. This is the same case and same context as the inscribed angles. Easy, right? Now, let us go to the third scenario. The third scenario will happen in the interior of the circle, meaning that the intersection will happen inside the circle. Now, how do we get the value of the angles formed? What you will do is you just add the 2 intercepted arc and then divide it by 2. In theorem, if 2 secants intersect in the interior of the circle, then the measurement of the formed angle or the angled form is equal to 1/2 the sum of the 2 intercepted arcs. Easy, right? So just remember, my dear math learner, if it is outside, then you subtract, then get the half. If it is on the circle, you just get the half. And if it is in the interior, you just get the half of its sum. That is how you know the measurement of the angles formed between the secants and tangents. Now, for you to have a concrete idea on how to solve using these theorems, let us consider some examples. Okay, math learners, we have here our exercises for us to have a concrete idea how to solve for the unknown values in terms of the angles formed by secants and tangents. Okay, let's start first with our circle A. In the circle A, the given is our radius. And we have also the tangent. Now, this is not considered as a whole tangent, but a portion of the tangent since it is a ray. Remember that a tangent is a line. Therefore, it should extend with arrows in both sides. Now, this is a portion of the tangent. So, therefore, this intersection between the radius and the tangent is what we call the point of tangency. Now, the question is, how do we solve for the angle that is formed, which is x, in this given scenario? Remember, my dear math learners, that when a radius and a tangent intersect in the point of tangency, that intersection is what we call perpendicular intersection, meaning that they form a 90-degree angle. Now, basically, if you consider or if you widen up your idea, if you extend this radius, this will become a diameter. Now, if this is a diameter, then the intersection or the intercepted arc given is this one, right? Having said that, we can say that the intercepted arc is a semicircle which is equal to 180 degrees. Now remember that the concept for the intersection on the circle is that you get the half of the intercepted arc. So the half of the semicircle is 90 degrees. So therefore, the value of our x here is 90 degrees. Thus, this is a right angle. Easy, right? Now, how about we have this given scenario? As we can see in our given scenario, we have a chord. Remember that a line contains a segment. That is what we call line segment. And a secant, as such, that intersect to a circle in exactly 2 points, contains a chord. If you extend this chord with an arrow and an arrow here, it will become a secant. Okay? Now, we have here a ray. Remember that a ray is also part of a line. Therefore, this is also a part of the secant because it touches the circle into 2 points. Okay. Now, the question is, how do we get the value of the angled form if we have these given values? Now, remember that this is the intercepted arc for this angle. Okay? So, therefore, whatever this is, you get half of that, and then that will be your measurement for the formed angle. Question is how? Now, as you can see, the other arcs were given. We have 100 here, and we have a 90 here. The whole circle is 360, right? So, therefore, 100 plus 90, that is 190. If you subtract it, therefore, this remaining arc is the measurement of our intercepted arc. So, 360 minus 19, that will give us 170. Okay? So, therefore, the measurement of the intercepted arc is 170 degrees. The question is, did we answer our problem? Not yet, my dear math learners, because we are finding the value of our x. And our x is the angle. Remember the theorem in case number 2, that when the angle is formed on the circle, what you will do is you get half of the intercepted arc. So, half of 170 is, very good, that is equal to 85 degrees. Therefore, the measurement of the angle is 85 degrees. Easy, right? Now, let us go to our circle C. In our circle C, what we can see here is that the angle is formed in the interior of the circle. Okay, so this is the intersection. Now, what does the theorem says if it intersects in the interior of the circle? Very good. What you will do is you get the sum of the intercepted arcs, and then half of it is the measurement of your angle. So, therefore, what we will do is, since this is our angle, okay, of course, this angle is also equal to this one because that is the relationship of vertical angles. Back-to-back angles are congruent. Okay, so what you will do is you get 92 and 160. You add them, okay? So that will give you 252. Now, the question is this our final answer? Not yet, my dear math learners. Why? Because we need to get the half of this one, and that will be our answer for our angle. So what is the half of 252? So what we'll do is you just divide it by this one, okay? So that is 1, 2, 5, that will be 2, 4, 12, and that will be 6. So the measurement of this one is equal to 126. Also, in this angle, that is also 126 degrees. And that answers your problem. Easy, right? Now, let us go to our circle D. Now, in circle D, we have here an intersection also in the interior of the circle. But, as we can see here, the intercepted arc is not given. So if this is our angle, the vertical angle of that one is here. However, the intercepted arc will be here. So how do we get the measurement of this one if ever the given is on the other side? Okay, my dear math learners, this is how you should do it. By having this as the given, what you will do is you add this one, divide it by 2, and you will get this value, this angle. Okay? So, what we'll do is 170 plus 150. That will give us 320. So, having 320, we will divide it by 2, and the answer is 160 degrees. Therefore, the measurement of this angle is 160 degrees, as well as this angle is 160 degrees. The question is, did we answer our problem? Not yet, my dear math learners, because we are finding this given angle. Okay? Since this is a straight angle, it means that that is 180 degrees, right? So if this is 160 degrees, then it needs how much in order to become 180? Okay, very good. That is 20 degrees. So this will also be 20 degrees. Easy, right? So, though my dear math learners, I'm sure that some of you are asking, sir, is the drawing is very big for a 20-degree angle, right? But let's just consider the facts between our given values. Okay? So, based on the facts, based on the given values, we have a correct answer for this given scenario. Now, let us go to our circle E. Okay, math learners, for our circle E, we have an intersection outside our circle. Now, as we can see, the given is a portion of the secant, and this one is also a portion of the secant. Why? Because it intersects the circle into 2 points. This one also intersects the circle into 2 points. Question is, if the angled form is outside the circle, how do you get the value of the angle? Okay, my dear math learners, if you consider our theorem earlier, if the intersection happens outside the circle, then what you will do is you subtract the bigger arc to the smaller arc and then divide it by 2. So basically, what we will do here is 100 minus 40. That will give us, of course, 60. And then, we divide 60 by 2, and we have 30 degrees. So therefore, the measurement of our x here, or the angle outside the circle, is 30 degrees. Easy, right? Now, let us go to our final example. Still, we have an example that is angles formed outside the circle. This is an example of a portion of the secant, and this is an example of the portion of a tangent. Why? Because it intersects the circle in exactly 1 point, and this is the point of tangency. Question is, how do we get the value of our angle? As you can see, my dear math learners, this portion of the secant also touches the circle into 2 points, as well as it touches the center of the circle. Therefore, if it touches the center of the circle, it means that this line segment is a diameter. And remember, diameters divide the circle into 2 equal parts. And that is a semicircle. So this is a semicircle, and this is also a semicircle. Now, we have our angle here. Okay? So, we have our first arc that is here, but the second arc is not given. So basically, if you have 86 here, you just need to get the remaining angle measure for it to become a 180 degree angle. So that is 180 minus 86, and that will give you, of course, 94 degrees. So therefore, this arc here is equal to 94 degrees. So by doing that, you just need to subtract these two. So 94 minus 86, that will give you 8. But we need to get the half of this one so that we will have the measurement of our angle outside the circle, and that is equal to 4 degrees. So basically, my dear math learners, we have answered all our scenarios, whether the angle is formed outside, inside, or on the circle. So I hope, my dear math learners, you have learned a lot of things about our topic for today. Now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time about our topic for today. This is still your free access math teacher, Ash. And always remember, it is fun to learn mathematics if we are together learning. Thank you so much. God bless. And if you do have some questions about our topic, do not hesitate to put your inquiries in our comment section below. God bless, take care, and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.